The topic of this video is constructing a model using variation. Let's solve this problem. The kinetic energy k of a moving object varies jointly with its mass m and the square of the velocity v. If an object weighing 12 kilograms and moving with a velocity of 10 meters per second has a kinetic energy of 600 joules, find its kinetic energy when the velocity is 16 meters per second. Alright, so we've already received a word of caution that we need to pay careful attention to the difference between a capital K and a lowercase k. There's one other thing that I want to share with you before we begin solving this problem. If you've ever taken a physics class, then you might recognize that there's a rather famous equation that's related to this problem. That famous equation is K, kinetic energy, equals 1/2 mv squared. I'm just going to mention that here and place it in the lower right-hand corner of the screen, and we'll see the relevance of how this connects to our problem when we're done solving it. All right, let's go ahead and proceed. I'd like to make a short list of the things we're measuring, the units of measurement, and the variable, just like we did in the last problem. So we have kinetic energy, which is being measured in joules, and we're using a capital K. We have velocity, which is being measured in meters per second, and we're using the variable v. And we have mass, which is being measured in kilograms, and we're using the variable m. Okay, great. So let's write our equation. Step 1, identifying what's doing the varying. Well, it says the kinetic energy, K, of a moving object varies jointly. K varies jointly. So we're going to start by writing capital K equals. Step 2, put a lowercase k in the numerator of a fraction. Step 3, identify the ly word, directly, inversely, jointly. Well, in this problem it says jointly. That means we're expecting two or more things to follow. So the first is with mass m, so that goes in the numerator. And the second is the square of the velocity. So v squared will also go in the numerator. Step 4, replace an empty denominator with a 1. Great. Now simplify. Anything divided by 1 is itself. So we get k is equal to lowercase k mv squared. And our job is to figure out what's the value of lowercase k. We can solve that with some information provided in the problem. For example, in this sentence we're told, if an object weighing 12 kilograms and moving with a velocity of 10 meters per second has a kinetic energy of 600 joules, so that's telling me capital K, lowercase m, and lowercase v. For example, 12 kilograms, that's telling me the mass m. Velocity of 10 meters per second, that's telling me the velocity v. Notice that in the equation v is squared, so here it's also squared, and has a kinetic energy of 600 joules. That's capital K, which goes over here. Now I can solve for lowercase k. So I get (600) equals 10 squared is 100 times 12 is 1200 times little k would be 1200 little k. Solve for little k by dividing by 1200 on both sides. And we get a very expected result. 600 divided by 1200 is 1/2. So little k is equal to 1/2. And when we put the value of little k inside this equation, it gives us a very famous physics equation. Kinetic energy is 1/2 the mass times the velocity squared. All right, so now that we have proven our famous physics equation, now we can use it to predict the future. Our last sentence says, find the kinetic energy, find capital K, when the velocity is 16. Now you might be thinking to yourself, wait a minute, don't they also have to give me the mass? And the answer is yes and no. The thing about an object is its mass doesn't change. So if the mass was 12 kilograms before, the mass is still going to be 12 kilograms after. So now we plug in. Capital K equals 1/2 times the mass, which is still 12, times the velocity, which has now increased to 16, squared. So we get 1/2 times 12 times 256. And we put all of that in our calculator. And we get 1,536 joules. And that is the end of this problem.